All right, so, we have the discussion questions to follow activity one. I would recommend taking each one of these, just kind of thinking about it for yourself. I'll kind of pause for a few seconds if you want to pause the video to really think about your answer. We're just going to run through these quickly. So, what information is needed to describe an exponential function? So, again, pause, come up with your response. So to describe an exponential function, we would need the growth or decay factor as well as the initial value. And I would hope at this point in this unit, we have really established that. Where on the graph do we see the initial value? Okay, so for that question, that would be the y-intercept where where the curve crosses the y-axis. What points on the graph of A can we use to help us find the growth factor? So again, pause is needed. For this one, you could use 0, 5, and 115, or you could use 115 and 245. What points on the graph of B can we use to help us find the decay factor? For this graph, we could have used negative 1 and 40, 0, 20, or we could have used 0, 20, and 2, 5. Why might negative 140 and 020 be a more strategic choice than 020 and 25 for finding the decay factor? So for this question, the x-coordinates of the first 2 points differ by 1. So the quotient could be used to find the factor of decay. It's a little more direct to find the factor of decay that way, because your input is only changing by 1. In the second pair, your x-coordinate changes by 2. So that would be a little bit more challenging. Okay, here's activity 2. It starts with a notice and wonder. So we can go ahead and pause the video, take a moment to record something you notice and wonder. Okay, the next part of this, you're going to go ahead on your own and answer questions 1, 2, and 3. All right, we'll go ahead and go over the answers. So if you're not quite done, be sure you've paused and take some time to do that on your own. Okay, so this has the answers to those 3 questions. Please read over them, compare to what you wrote, make any changes as needed. If there's questions you need to ask me on Monday, be sure that you know what that is as well. All right, here are some discussion questions for activity 2. So you can, think about what your responses would be to each of those. For the first question, the solid graph started off lower than the dash graph. What does this mean? The mole population represented by the solid graph is smaller or covers a smaller area on the wall than the one represented by the dashed graph. The next question says, after some point, the solid graph passes the dashed one. What does that mean in this context? So think about what you would say to that. Okay, this one says the mold population that started out covering a greater area on the wall is surpassed by the other population, so it is growing at a slower rate after that point. The next question says, what does the intersection of the 2 graphs mean? What do P and Q represent? The 2 mold populations are the same at the time P, with population covering an area of Q squared inches. Okay, so just to kind of sum up that activity. All right, I will post the slides, so if you'd like to read through the lesson debrief, you are welcome to do that. This is your cool down. You should be receiving a paper copy of that. Please be sure that that is complete, and you can either hand it in before the end of class or bring it with you on Monday. These are also the practice problems that you will need to complete for this lesson. Those will be due by Monday as well. Thanks.